Have you previously? All right. So polymerization is basically the combination of the smaller units called monomers to make a large molecule called the polymer. Polymerization is the joining or combination of the small molecules monomers to make a one large molecule called the polymer. And these polymers are basically the part of our daily life. Whatever you see around, like even the one you are carrying in your hand, for example, you are carrying the mobile phone, then the plastic of that mobile phone or the covering on that mobile phone is made up of polymer. The pen you are writing with must be made of some material that is also a polymer. And there are so many things, like we cannot count how many things are not made up of polymers. So everything in our today's life is becoming part of the polymer, and there are numerous types of the polymers that exist, and they have their different properties that are made to use for our benefits. Some are very much flexible, some are very much hard, some are easily decomposed, and some are never decomposed. There are some which are very reactive, some are very inert. In fact, even the even some military also uses the polymers. For example, the bulletproof jackets with the soldiers wear and the bulletproof windows, they are all made up of polymers. So polymers is becoming a part, or is becoming a very much necessary for our daily life. Now we have to check how these polymers uh, are basically being produced, and which other monomers or types of polymers are there. So starting from the addition polymerization means that a kind of a polymer which is formed by the addition of the monomers. So when monomers are added together into each other, then a single polymer is formed. You have studied in the organic chemistry previously that an addition reaction involves the combination of two reactants, let's suppose A and B, to make a one single compound, and no byproduct is produced. Just one single molecule is formed by the addition of the two reactants. In the case of polymers, the two reactants in these cases will basically the monomers itself. They will be just monomers of the polymer. They will be combined with each other to make one single large molecule called the polymer. So one specific example in this case is the ethene. Ethene, you have studied that its formula is CH2 double bonded CH2, or in short form you can say C2H4. And there are other representation of the ethene. This is the displayed formula of this ethene, and the next one is also kind of displayed formula, except that the atoms of carbon are represented by balls. So this is one example of the polymerization, in which we have just seen the structure of the monomers. These are the monomers. Now how do they combine with each other to make a polymer? They are combined when the ethene molecules are bonded with each other under a high temperature and pressure, and in the presence of an initiator. Initiator can be any specific compound which has a role of initiating the reaction. So this will be a compound. So the ethene molecules, there are so many ethene molecules in our sample, and they are mixed with each other under high pressure, temperature and initiator. And when these molecules combine, they will give you one single large molecule which have no ending. To some extent you can say they have no ending, although there be an ending to at any larger point, but currently we will say that there will be more chains on one side and more chains on the other side of this large molecule. So as a result of this large compound, you will get one polymer. The name of this polymer is the polyethene. That's the name of this polymer, polyethene. Poly is written outside the bracket, and inside the bracket we write the name of the monomer. So this is one way of representing the polyethene, and you can also see this structure in another book here. This is from your other book of the Edexcel IGCSE. They have shown another way of showing the polymer. This is one ethene molecule, this is second, this is third. Although there will be thousands of monomer molecules in our sample, but for our simplicity we are showing only 3 monomer molecules here. And now these 3 monomers are combining with each other, and they are producing one single large molecule which contains all the 6 carbon atoms, 2 from here, 2 from here, 2 from here, and now they are combined with each other to give 6 monomer molecules, 6 carbon atoms. 6, and it has shown 6 carbon atoms. But this structure is not ended, because you can see they are dotted on this side and dotted on this side, which means this is continuing with other monomer molecules. So as a result of this combination, one single large molecule is formed, which is called the polyethene. Is that clear up to this point?
Yes.
Now what other changes you are looking here? You can see that the double bonds present in the monomer molecules are now broken. This double bond is now broken into a single bond in the polymer. You do not see any of the double bonds. So what basically is happening here? It shows that whenever we have any molecule with a double bond, it is broken into a single bond, and that double bond and that single bond is combined with the other monomer molecule. You can see here that the double bond is converted or broken into a single bond. Now the one half portion of that double bond is connected here, and the other half portion of the double bond is connected over here, and the central single bond is still the same. It is still present as a single bond in the polymer molecule. So that's how it is done. The double bonds are broken into a single bond, and the remaining bonds are used to make bonding or joining with the other monomer molecules. Now what else do you see here? You can see that we can represent the monomers ending. We can represent the monomer endings in terms of the continuation bonds. These dotted lines on the either sides represent the continuation bonds, which means these sides will still bond with other molecules of the ethene to make this chain even larger. So these are called the continuation bonds, and there are no continuation bonds in the monomers, because these are the units of the polymer from which this polymer was made. So the continuation bonds are present in the polymer and not in the monomers. The better way of representing these continuation bonds is like this one: solid lines. You need to represent the solid lines for the continuation bonds. So we have these different ways. You can also see the continuation bonds are shown in this diagram as well. These are the continuation bonds, this one and this one. These show that there are still more bonding, there are still more monomer molecules on the either side of this polymer molecule. Is that clear? Alright, now generally speaking, we have almost 4,000 to 40,000 carbon atoms in a single polymer molecule. About 4,000 to 40,000 carbon atoms. In the monomer, you can see that they are just 2 carbon atoms. But when they are combined, if I say I want to have a polymer with 4,000 carbon atoms, then can you tell me how many monomers would I need in case of polyethene?
What?
If I say that I want a polymer containing 4,000 carbon atoms, 4,000 carbon atoms in a polymer, then how many monomers I need to make this polymer?
You would need 2000.
Yes, exactly. I would need 2,000 monomer molecules, which are ethenes here. So that's right. And this you can calculate if you have other types of the monomer molecules and also the required amount of the carbon atoms in the polymer molecule. So that's how we can find it. Now there are some other terms used here. This left side is a monomer of the polymer and the right side is a unit. It is called a repeating unit. This is a repeating unit of the polymer. The repeating unit is basically shown. The repeating unit is basically shown. The repeating unit is basically shown for any of the polymer. How can we derive the repeating unit of a compound? You have to select one point in the polymer and another point on the polymer which you can see is being repeated repeatedly. So since it is a very simple example of ethene, I will select this portion that these two parts or this whole region is being repeated repeatedly. So this portion will become my repeating unit. So I will write this repeating unit in this way. I will have this as the repeating unit with carbon atoms and hydrogen atoms up and below, and these continuation bonds. Now as I don't know how many monomers I have used here, I will write n for this. N represents that there are so many number of the monomer molecules which are bonded. So this n will become subscript n in the structure of the repeating unit. The same n is shown over here. Are you getting the point?
Yes.
Alright. So you can see the differences between the structure of the monomer molecule and the repeating unit. For the repeating unit, you will have the square brackets and also you will have the n at the bottom. These are the ways of representation of the repeating unit, and for the monomer you will need to use the same molecular formula of the monomer molecule which you were given at the start. Like here in this case you were given the ethene molecule, so ethene is shown here. Ethene is shown in this structure. So this ethene will be multiplied with the n, which represents how many number of monomers are there. And there are no continuation bonds here, and there is a double bond which is just the actual formula of the compound for ethene. Now this is one example of the polymer which we have now discussed. Do you have any question from this portion?
No, I understand.
Alright. Initiator is what? It is the compound which is used to start the process, and don't confuse it with the catalyst, because catalyst is something which is not used in the reaction. However, initiator is a compound which is used in the chemical reaction. So we have discussed about the repeating unit and the monomer. Now there are two further types of the polythene. One is the LDPE, which is called low density polythene, and the other type is high density polythene, HDPE. Low density polythene and high density polythene, and they have their own specific purposes and uses for the for like our uses. Give me a minute, please. Are you there?
Yes.
All right. So the two types of the polymers are HDPE and LDPE. They are based upon their uses. So the LDPE is used to make polythene bags, which you do you use polythene bags in your country? These were, I think, a few years back, these were commonly used everywhere in every countries, but some countries have now banned these polythene bags. So these were made from the polythene compound, and these were very much flexible but not very strong. Now the use of HDPE is for the greater strength and the rigidity. That's why they are used to make milk bottles and other hard materials. Now these are the different types of the polythenes. Now about the how to find the polymerization reaction for an alkene. You just need to do is to cut these double bond and connect that double bond with half portion on one carbon atom and half portion with the other carbon atom. Now there is another type of the polymer, which is the polypropene. The polypropene has the monomer propene. The propene is CH3CH double bond CH2. Are you familiar with this structure? CH3CH double bond CH2. Have you seen this structure before? Propene.
Is it the isomer like in which like there's a methyl?
No, there will be no isomer here. It has no other isomer. It is without isomer. It's just a member of the alkene family. The first one is ethene and the second one is propene. All right. Is that clear?
Yes.
Okay, now how can we make a polymer out of this compound propene? This propene will also be the monomer in the polymerization. This is the monomer. Propene is a monomer here. Now we can see the structure of the polymer from the other compound from the other book. Here, this is the propene. Now this propene will be connected or bonded with another propene molecule having the same structure. Now when they will combine with each other, what observation would you think will be there? What changes will be there during the
The
poly?
double bonds will be broken.
Yes, this double bond will be broken into a single bond, and what else? What else, Hania?
Isn't that the only observation we can see?
No, no. You have to convert this. You will have to break this double bond into single bond. Also, you have to connect another propene molecule either on one side or the other side, or both. You will need to add propene on this side and on the other side as well. That's what you are doing, because you are making a polymer. So to make the polymer, you have to add up the monomer molecules. You have to join the monomer molecules. Isn't so?
Oh, okay, yeah. I didn't get what the other one was. That's why I understood.
Alright. So you will combine or join the monomer molecules, and after combining them or joining them, you will also show the continuation bonds on the sides. One continuation bond over here and another continuation bond on the other side. That is used to indicate that more of the monomer molecules can be joined with this polymer molecule, right?
Yes.
Okay. Now after doing this, you will get a polymer. In this book, you are looking at the ball and stick model of the propene. If it is more easier, then you can follow this structure, or if the other way is more easier for you to understand, you can follow this one. So it depends upon your understanding. They have not shown the carbon and hydrogen atoms in their symbols. Instead, they are representing them in the form of the balls. So what we have the more chain on one side and more chain on the other side, which means it indicates that more of the propene molecules can be bonded on the either sides. Now how can we represent the repeating unit and the monomer part of it? This is the monomer part, because it is made up of propene molecule, and this is the repeating unit of this polymer repeating unit, and the n, which is the subscript here, is actually the multiplier in the monomer part. So these numbers are same. Is that clear?
Yes.
Now about the uses of the propene. Where can we use these propene? Propenes are used to make ropes. It is used to make crates. Do you know about the crates? What are crates? Have you ever been to the market, fruit market especially, fruit and vegetables market?
Yes.
They put the vegetables and fruits in the large plastic containers.
Oh, okay, yeah.
These are called the crates. So those crates are made up of plastics, and they are made up of polypropene, because polypropene has a hard material. It has strength and rigidity in its properties. So then we have another type of the polymer, which is in a short form called as PVC. Have you seen this word before, PVC?
I think so.
PVC are mostly said as PVC pipes. PVC pipes. These are pipes made up of plastic, which are frequently used during the construction of houses or construction of buildings. So these pipes are made up of a polymer. The polymer name is chloroethene. Like the monomer of their polymer is chloroethene, and we can also call it as, in the other words, as vinyl chloride, which in short form is VC. And when we make a polymer of this vinyl chloride, the polymer of this compound will become PVC. That's PVC. But you will also come across this name chloroethene, and its polymer will have the name polychloroethene. It is not abbreviated as PVC basically. Instead, the short form PVC is from the polyvinyl chloride. The difference between these names is that one of the name is according to the systematic name, and the other name belongs to the trivial name. That's the difference. Anyways, these are the same names of these are the names of the same polymer. Now in the case of PVC, the monomer is chloroethene, and its structure is like this. We have a carbon-carbon double bond, and one carbon has two hydrogen atoms bonded to it, and the other carbon has one hydrogen and a chlorine atom bonded to it. It is just a modification of the ethene. Like in ethene we have hydrogen atoms in both the carbon atoms, but if you replace one of the hydrogen atom, any of the four hydrogen atoms with the chlorine atom, you will get chloroethene. Is that right?
Yes.
So just by replacing one hydrogen atom with the chlorine, you will get the chloroethene. So the polymer of this monomer will become polychloroethene. And when they are combined with each other, you will get this type of the polymer here. This is the polychloroethene, but you need to show the continuation bonds on the either sides. The monomer and this repeating unit of the PVC is shown here. This N is put here and a subscript N is put on the repeating unit. I hope it's clear to you.
Yes.
Alright. Now the uses of the PVC, where it is commonly used. Since it is quite strong and rigid, so it can be used for the water pipes or replacement windows. Water pipe, as I told you before, the one which is used in the construction of the houses or buildings. Also it is used in the replacement windows. It can also be made flexible by adding plasticizers. This makes it useful for sheet, floor coverings, and even clothing. These polymers don't conduct electricity, therefore PVC can be used for the electrical insulation. So these are the properties of the uses of the PVC. Now another type of the polymer is made from the monomer, which is tetrafluoroethene. Tetrafluoroethene has the structure this one. In this structure you can see that it is again a modification of the ethene. As you know that ethene has two hydrogen atoms on both the carbon atoms. When you replace these hydrogen atoms with the fluorine atoms, all of them. If you replace all of these hydrogen atoms with the fluorine atoms, you will get the compound tetrafluoroethene. This is the tetrafluoroethene, and the polymer which is made from this monomer is called Polytetrafluoroethene, and its abbreviation is PTFE. Polytetrafluoroethene. Is that clear?
Yeah.
Now this is the structure of the monomers of the tetrafluoroethene, and the polymer is this one, polytetrafluoroethane, with more chains on the sides, on the side of it. So, and the common name of this polymer is Teflon. Teflon is more commonly used as the name of this polymer, polytetrafluoroethene. Teflon. Teflon has many uses in our daily life as well. It is used in making the non-stick coating for pots and pans. You know that you must been working in the kitchen, and you must have seen that your utensils have black covering on it, especially the frying pan. Is that so?
Yeah.
That black covering on the frying pan is basically made up of the polytetrafluoroethene, PTFE, and it is a non-stick material. Non-stick material means it will not stick with the food which you are cooking. Those particles will not stick to the surface of the pots and the pans. That's the purpose of this polymer, to prevent the pots and pans from becoming reactive, or you can say decomposing, or other way degrading with the food particles. That's the purpose of using this polymer. It is very unreactive due to the strong carbon-fluorine bonds and can be found lining containers for corrosive chemicals. Is that clear up to this point?
Yeah.
All right. Now, a practice of working out the monomer from a given addition polymer. If you are given any of the addition polymer in your question, then you have to find out the monomer molecule of that polymer. You have to find out the monomer molecule. So let's suppose if you are given this compound in the form of the polymer, then how can you determine the monomer of this compound? You will look at the repeating parts of the whole chain. You will see for the repeating sections. You can see that C6H5 is repeating repeatedly, and you also notice that it is repeating after every either you can say one carbon atom after every one carbon atom. So the portion which you will select is this portion of the C2H5 along with the carbon and the other hydrogen atom, and then you will also select the next carbon atom which is bonded with the two hydrogen atoms. Now this portion will become the repeating unit. This is the repeating unit of the polymer. You will not include the longer portion. That will become incorrect. This is wrong. You will select the smallest part of that polymer which is repeating repeatedly. And after finding out the correct repeating unit, you can also find out its monomer molecule. The monomer molecule can be converted from the repeating unit. You can see that these single bonds are basically removed and they are converted into one double bond. Now this one double bond is shown in the monomer and the continuation bonds are removed. However, you do not know how many carbon atoms were there in this whole polymer. So it means that you do not need to mention the number at the front of this monomer or at the subscript of this monomer. You do not need to mention that, but if you are given the value or if you are given any n letter in your question, then you can definitely put that value or the n letter in the monomer part and as well as in the repeating unit. Is that clear?
Yes.
All right. Okay, now the next portion is based on the disposal of the addition polymers. How can we dispose of these polymers into the surrounding, into the environment? Because you know that polymers are becoming increasingly produced in our daily life, and we are also discarding those polymers after using them in one way or the other. We have to get rid of these polymers, but these polymers are not very easily decomposed or recycled in the environment, so different ways of disposing them off. Some of the polymers are also biodegradable and some are non-biodegradable. Biodegradable means something which can be broken down by microorganisms, using like bio stand for living organisms here, and the thing which can decompose a polymers include the microorganisms, and microorganisms included here are bacteria. We have fungi, we have yeast, etc. So these microorganisms can play the role of decomposing the polymer, but the requirement is that the polymer should be made up of the biodegradable material, and other polymers which cannot be broken by these microorganisms are referred to as non-biodegradable. So how can we discard or get rid of or dispose of those non-biodegradable? One way is to dispose them in the landfill sites. Have you ever seen landfill sites? It is a place where a lot of garbage is thrown. Like it is very much hollow areas, or there are holes in the ground where tons and tons of the trash is dumped or buried. That site is called a landfill site. Is that clear?
Yes.
And the second way to dispose them is to burn them, or it is called incineration. Incineration includes burning those plastic materials or polymers. As a result of burning, there is a lot of heat energy produced that can be utilized in the electricity production. But again, burning of the polymers can also include the formation of the hazardous compounds or gases. For example, carbon dioxide is produced in a huge amount, and that carbon dioxide can contribute towards the global warming. And other toxic gases can also be produced during burning. For example, formation of the carbon monoxide and hydrogen chloride. What is the formula of carbon monoxide?
HCO.
Yes, CO. So carbon monoxide and HCl gases can also be produced. Now there is a small table for the differences between landfill and incineration. So landfill can the benefit of the landfill is that no greenhouse gases or toxic gases are produced because we are not burning them. Since we do not burn them, so these gases are not produced. But the disadvantage is that you have the ugly appearance of that area. There is a lot of smell, and the working on the landfill side is very much noisy. So people do not prefer to live or wants to live near that area. And we occupy a large of land because landfill site requires total wastage of the land for other purposes, and then the waste that we dump there takes a lot of years, thousands of years, to be completely decomposed into up to the microscopic level. So it doesn't go in a fast way. Takes a lot of time. On the other hand, incineration requires the advantages require little space because we are basically burning them. So which means even if you have collected some of the material, it will be later on burnt, and that little space can again filled up by more of the trash later on. So that's why it requires little space. Advantages also require that the formation of heat can be used for the electricity production. But disadvantages include that it is very much expensive because we have to design it. We have to design a plant where the incineration can be done, so it is costly. And then we have the formation of the greenhouse gases like carbon dioxide, methane, etc. during the incineration. Also the toxic acid, for example HCl, can also produce. And at the end, the ash which is produced, like those solid compounds which are not completely burned or broke down into the small pieces, those compounds must still be disposed of at the landfill sites. However, those compounds are lesser as compared to the actual landfill. Now we have completed one portion of the polymers, portion of the synthetic polymers. The other portion is the the condensation polymers. Condensation reaction. Do you remember about the condensation reaction?
When smaller molecules are joined together to make a larger one and produce water.
Yes, good. It is the type of the reaction in which the two molecules are combined with each other to make a larger one, along with the formation of a smaller molecule. Smaller molecule can contain water, ammonia, carbon dioxide, carbon monoxide, HCl, etc. So the same concept is applied here for the formation of the polymer. The polymer in this case will be formed as a result of the condensation reaction. Like we have a monomer. For example, this is a monomer in which there are two carboxylic acid functional group which have two functional groups of the carboxylic acid, one at the one side and the other at the other side of the molecule. Now this is a compound containing a carboxylic acid functional group within the same compound, and the other compound contains the functional group of the alcohol on the either sides. So this compound has alcoholic functional group on the other sides of the compound. Now when we studied in the previous topic about the esterification, what we studied, how can we make the ester?
By reacting the carboxylic acid with alcohol.
Very good. By reacting the carboxylic acid with alcohol. So we stated that we have an OH group of the alcohol and we have the carboxylic part of the carboxylic acid. Now tell me from where the reaction takes place, which parts actually combine with each other.
The OH from the carboxylic acid is removed and the H from the alcohol.
Very good. The H of the alcohol and the, let me change it. You're right. The H of the alcohol and the OH of the carboxylic acid, they are combined with each other, and as a result of this, water is formed. So this portion will be eliminated and it is the H2O. The same is happening here. In this case, the monomer has carboxylic acids on both sides, and another monomer has the alcohol groups on the both sides. So carboxylic part of one monomer will be bonded with the monomer with the alcoholic part of the other monomer, and it will remove the water. Then the polymer that will be produced will contain this ester group in it. Here you can see that this is the ester linkage. This ester linkage is present within the polymer, and the ends of these polymer molecule will still contain the carboxylic acid functional group, and the other end will contain the alcoholic functional group, and these functional group can still bind or bond with the other monomer molecules. This part can further bond with the carboxylic acid of the other monomer, and this part can bond with the alcoholic functional group of another molecule. So this continues for the formation of the condensation reaction, and here in the middle of this portion you can see that water molecules are removed. Water molecules are removed in this part. So that's how we can make a polymer using this esterification reaction or condensation reaction. The particular examples of these compound includes the diol, and the other is compound is dioic acid. Diol means a compound containing two alcoholic functional groups. That alcohol is called the diol compound. So let's see the example of it. So here
I'm still a bit of conversation for at the beginning.
and then it is about the another example here. The other example included here is hexane 1,6-dioic acid. Like this is a type of the carboxylic acid which contains 6 carbon atoms, and the alcohol is again the same, which has only 2 carbon atoms. It is not different. Now when they are joined together, you will get a polymer of this type. This is a polymer here. This whole compound is a polymer, along with the chain on this left side which can continue, and a chain on the right side which can be continued. And the water or molecules are removed from this portion. You have to remove one water molecule from this portion, another water molecule is removed from this portion, and another water molecule is removed from this portion. So in total 3 water molecules are shown to be eliminated when these monomers are joined with each other. Is that clear?
A bit confusing.
This one?
Yeah.
Basically they have included, if you look at the blue ones, how many blocks do you see here of the blue ones?
2.
2. Basically these blue ones are one type of the monomers. These belong to one type of the monomer. This is the dioic acid made up of the carboxylic acid. This is, and this one. These are the same monomer. Do you get this?
Yes.
If I label them as A, it will become more easier. These are basically the A monomers, and the blue ones, the red ones, I will represent them with B. These are diols, B, and this is B. These are the same monomers. Is that clear?
Yes.
Now I will write with AB to make it easier. So the A dioic acid is bonded with the B monomer, and the B monomer is bonded again with the A monomer, and A monomer is bonded with the B monomer. Now when the water molecules are eliminated, then what water molecule will be eliminated from here? One water molecule will be eliminated from here during condensation. Are you getting the point how the condensation is done?
Yes.
So here you can see that these will eliminate three water molecules. A bonded with B, B bonded with A, and A bonded with B monomer. Is it clear now?
Yes, understood.
So you just need to see that A are the same monomers, B's are the same monomers. And when any A connects with B, a water molecule is eliminated. Whenever B is bonded with A water molecule is eliminated. Disposal of the polymers. Such type of polymers, you should know, such type of polymers are called polyesters because it involves the condensation, and condensation is being done between the carboxylic acid and the alcohol. So an ester is produced. An ester is produced as a result of this condensation. So that's why such polymers are called polyesters. Is that clear?
Yes.
Okay. Now these esters are more reactive as compared to the addition polymers because of the presence of the ester linkage. So these esters can break down eventually, but they will also take hundreds of years. So as a result, the scientists had developed the biodegradable polyesters, which can be degraded more quickly as compared to the non-degradable polyesters, which means polyesters can degrade naturally, or you can say biodegradably. They can degrade, but to make them more quicker to degrade, they are converted into biodegradable polyesters. So biodegradable polyesters can be made from the lactic acid, which can be obtained from the cornstarch, and when it undergoes polymerization, it forms a biodegradable polyester, which is called PLA or polylactic acid. It is called PLA or polylactic acid. Sorry for this. So PLA or polylactic acid is basically a kind of a polyester which is formed by using the lactic acid. So and they are being used in the plastic bags as well as in the surgery for the internal stitches. Like whenever an operation is done or surgery is done on a human body, then it requires to stitch those parts of the human body. Those stitches are made from the polylactic acids because they can be easily degraded inside the human body, but definitely it will not take like hundreds of years to degrade them. They will definitely degrade it in a span of few days or weeks. So this is the structure of the lactic acid. This is the example of the lactic acid monomer, which is used to make the polylactic acid. And here you can again see that one part of this polylactic acid contains the alcoholic part, and the other part contains the carboxylic acid part. Instead of using two different monomers, one of which was the alcoholic part and the other was the dioic acid part, this kind of monomer contains both the parts, the alcoholic part on the alcoholic part on one side and the acid part on the other side. Is that clear?
Yes.
So the same condensation will be carried out, and as a result of this, a polyester will be produced. Now here I have completed your chapter of synthetic polymerization. Do you have any question?
No, I understood.